Hello, ladies and gentlemen. Welcome back to the AM4U stage. This year, more than 30 French companies, associations, and research institutions will be exhibiting at Formnext and presenting their range of services to the international trade audience. Reason enough for us to have them here on stage. The French AM sector will represent a very diverse portfolio of products and services along the entire process chain, from materials, hardware and software, engineering to post-processing and various services. French exhibitors will present their products and services at the Formnext French Pavilion in Hall 12C33. This afternoon, we will get the chance to get to know various companies and their products. Our first session this afternoon will be on the topic how the network of excellence in the field of AM research serves international products. And I welcome on stage with me the following speaker. To my left, Leo Talotte, IRMA from the Institute Carnot MICA. Hello, Leo. Good to have you here. Then we have Bruno Lacey.
Almost.
Lacey?
Kaici. Thank you, sir.
Okay. Sales engineer from the Institut de SOUDURE. Yeah? SOUDURE. Then we have Franck Simon, scientific coordinator, cluster CIMES. Is that correct? Thank you. Good to have you here. And we have Benoit Verquin, AM expert of CETIM. Great to have you here. Leo, we want to kick off with you. You have 4 minutes. Please go on with your presentation.
Okay, so hello everybody. I am Leo Talotte. I'm a materials engineer at IRMA, which is part of the Institute Carnot MICA. I will present you quickly a prototype that we made, combining FDM printing and low-cost AFP layup. So, AFP layup, automated fiber placement, which is carbon fiber placed on a mold by a robot. It's a very cool technology because it offers very high-quality composites. But it also needs very high-cost softwares, molds, calibrated materials. So for new markets that want to address the automated composites technologies, they are not able to pay for all that quality. So they need smaller parts. They need very short design to manufacture times. It is markets that we have near IRMA in Brittany, like offshore racing, or design, or medical applications. So for all those markets, you don't need a metallic mold with 5-axis machining and 0.1 millimeter precision robot. It's a kind of craft composites. You need to address every client differently. So at IRMA, we do FDM printing. We make our custom machines, and we love the challenge of combining different techniques, like printing materials with carbon fiber inside. And for this project, the challenge was to produce the mold and the part in less than a week of work. So to do this, we designed a mold. The design is made on the Rhino 3D software. It's a double curvature mold, around 40 centimeters wide, with a hollow structure, and we use the additive manufacturing to make some reinforcements in the structure of the mold and to add some functions like fixture and probing points to the printed mold. So the printing takes place on a Stratasys machine, Fortus 900, and it's printed with ABS-based material, around 40 hours of printing, and then after that, to reinforce the mold, we pour epoxy foam inside the structure to make it vacuum resistant. You need, of course, a bit of surface finishing after. I apply a epoxy gel coat. It's not the best solution. Next time, I will apply a PTFE film. And once you have the mold, you can do the programming. And one thing with this AFP XS machine is that you do the programming in the same software as the design. So it's a plugin named Add Composite, which is used for path planning and robot simulation. And all of that is in the same document than the design part.
Leo, you have 1 minute left. I need to be the nasty timekeeper so that the others can do as well.
OK, perfect. So after a little probing and mold placement in the virtual machine, we can do the layup. You can see that it's a very little robot, but little robot equals little problems. So it's epoxy carbon prepreg, and then it's curing in an oven at a low temperature, around 80 degrees, with a long cycle, just with vacuum, no autoclave, no pressure. So you have seen just pictures of the part, and if you want to see the real part, you can come and see us at the Hall 12 and the booth C21. Thank you.
Thank you, Leo. Thank you so much. Sorry for interrupting, but I need to keep the timing. Bruno, stage is yours. Thank you so much.
Thank you very much, Sven. So, just expecting the presentation. Should I start? Or?
Yeah, you can click.
OK, wait. First, I'm just, wait.
You can go back. Yeah.
There is. Thank you. Thank you very much, Sven. So I'm really happy to be here today to give this presentation. I'd like to thank the Carnot network, in particular Carnot MICA and Carnot ICL, as well as thank the organizing team. Thank you, Andrew and Sven. And of course, I'd like to thank our partner, PCM, both for the trust in the project and for allowing us to give this presentation today. So PCM is manufacturing progressive cavity pumps for almost a century now. And the pieces that we have been working on are the rotors and the stators that you can see in this video there. Those are screw-shaped pieces, and their complexity is what gives the idea of doing this by additive manufacturing, specifically wire arc additive manufacturing, so WAM. So, as I told you, we did it in WAM. Why did we do that? First of all, because, as you can see, PCM uses a wide range of different materials for their pump. And for WAM, as long as you have a wire, then it's easy to manufacture. So first advantage is this one. Second one is those parts, as you've seen in the video, are highly complex. And so they are produced in small batches. This is WAM is so suitable to make them. So how it goes? What do we do? First, we need a digital model of the piece. Then we'll try to find some deposition parameters. Then find a deposition strategy. Fail sometimes. And then, of course, manufacture the parts before the finishing. So better than a photo, here's a video of the manufacturing in WAM of one of the pieces. If you get some quick eyes, you can see that some people are around while it's manufactured. This is because it was still a development stage. So by using the flexibility of WAM, we were able to reduce tremendously the mass of the final piece, as well as improving the geometry. This gives us an overall 30% of upgrade of the performances of the pump. So the surface condition is not exactly the one that you can find in other additive manufacturing processes like powder. Yet, we ensure and we make sure at every stage of the manufacturing that by 3D scanning that there were enough material to do the machining afterwards. As I told you, the visual appearance can be a bit scary sometimes, but stay still. We made sure and we ensured that after the machining, the pieces didn't present any unacceptable defects. For confirmation, here's the pieces that you've just seen being assembled in one of the biggest pumps that PCM produces. So we talked about the geometric aspect that were good, but what about the mechanical properties? Actually, here is a comparison between the same material of the one we use in the PCM studies, building walls, and you can see that the comparisons say that the mechanical properties on the pieces that we produce in WAM is highly better than the one you can find on the specification sheet of the A240 stainless steel material. So I think I'm on time then. Thank you very much. Here's our partner, our proud partner, Mr. Eric Auger, in front of a fully assembled pump. So thank you again, PCM, for your trust, and thank you again, Carnot, for making our life easier every day. Thank you.
Thank you so much, Bruno. Excellent presentation. Let's head on with Franck. Franck, stage is yours. Enjoy. You can use, do you have the clicker? The clicker?
Oh, sorry.
Ah, here. Bruno has stolen it. So enjoy your 4 minutes.
Thank you. So after the technical presentation, I will present you the national cohesion on metal additive manufacturing. So it's a French national cohesion. It was created 1 year ago, in October last year. The aim is to coordinate the efforts to competitiveness of French players to help companies. You can see the mapping and structure of the players in the ecosystem. We are principally present on 3 regions in France. So in Île-de-France with IFH, in Nouvelle-Aquitaine and Occitanie with ADIM Alliance, and in Auvergne-Rhône-Alpes region with Initiative 3D. So there are many laboratories and technical centers you can see on the screen. It represents more than 100 million euros devoted to R&D IM players for over the last 5 years. And there are more than 300 people who work on the R&D project. And the other one characteristic is there are 70 equipment on manufacturing and more than 200 equipment on characterization. Now I will do a focus on Initiative 3D. The other structure network are like Initiative 3D, but I know better this one because I manage it. It comes from the competitiveness cluster CIMES, and there are six technical centers like the CETIM, IPC, or CTIF, and others with platforms like the CEA. And there are 8 laboratories issued from 6 engineering schools, like you see in the screen. So the aim is to have a network of skill and resources, and only on metallic additive manufacturing. And there are some R&D projects with a small project from 200 euros to 20 million euros. And there are many groups who work on design, materials, process like powder, bed fusion, direct energy deposition or indirect process. And there are training programs on this group, for technicians, for engineers, and for company resourcing. What the aim is, it's for assisting the emergence of new competitive players on the international scene. It's promoting synergy between these initiatives. It's for giving visibility for industrial manufacturers and on the international market. And it's for optimizing investments and consolidating results. With coordinating, interacting, and sharing, and promoting gateway and access, and focus material resources and human skills. The next step will be to have some collaborative project between all the network, and we'll do a metal additive symposium in 2024, in March. Thank you.
Great, awesome. Thank you so much, Franck. I think it's already worth listening to you. I will hand over to Benoit. Benoit, stage is yours.
Thank you. I would like today to give you an overview of French R&D network and its organization. So at the first level, you have the French government hub Solutions Industrie du Futur, which coordinate initiative which leads to the transformation of our industry thanks to novel technology like robotics, artificial intelligence, and of course additive manufacturing. France Additive is a French association which gather all the stakeholders on additive manufacturing, from academics to industrial user or supplier of the technology for all domains of additive manufacturing, from polymer application to concrete construction application.
So reden die alle 6 Minuten.
For metallic, CETIM is coordinated cohesion, the French national cohesion, and which gather the most relevant laboratory in this field and company, and it was just presented by Franck just before. And to complete the map of this R&D network for research and innovation transfer, you have the Carnot Institute network, which gather French public laboratories certified by our French Ministry of Research, committed to developing research collaboration in order to develop innovation and improve the business of all size of company, from SMEs to larger group. So on additive manufacturing, the Carnot network has 8 Carnot institutes who are working in synergy. It means that if you have needs, you have one contact point is able to, and you will be able to access to all this network. This network represents around 300 experts on 27 platforms. And all these people are working on all the value chain of additive manufacturing, from the creativity innovation for the development of a new product to the standardization. And if we see at our offer covers all the whole value chain of additive manufacturing, from technical economical study to the support of integration of this novel technology in your workshop. So we do such activity, of course, at the French level, but at the international level. And of course, I invite you to visit our booth on all 12 booths C21. You will discover many applications, many success stories, and you have 2 success stories shown this afternoon on many applications, polymer, metal, concrete construction, small parts, big parts, and we will be happy to present all this innovation. Thank you.
Awesome, Benoit, thank you so much. Benoit, thank you to the others. Was already a great insight on your market, and I think this was a perfect round of Benoit. Thank you so much. Great to having you. Please visit these guys at Hall 12. See you there. Thank you so much. Okay, bye-bye.
Bye.
So this was our first session, and we will head over to the next session. But before that, you will have 4 minutes of highlights of the exhibition. See you in 4 minutes.